March 2026. The International Maritime Organization issues an emergency appeal for safe passage through the Strait of Hormuz. Mines threaten the choke point that carries a fifth of the world's oil. The Navy's answer is 3 littoral combat ships in Bahrain, a class haunted by cracked hulls, failed propulsion, and calls to scrap the program. But open-source tracking revealed something the Navy had not advertised. 2 of those 3 mine hunters were not in the Gulf. They were not even close. How did the Navy's most broken warship end up at the center of a shipping crisis, and what happens when it is not there? On March 19, 2026, a wire from the International Maritime Organization cut through diplomatic channels and shipping networks with a single, urgent demand: a safe corridor through the Strait of Hormuz. The language was blunt. Nearly 2,000 commercial vessels carrying over 20,000 seafarers were trapped west of the strait. 17 ships had already been struck, some by missiles, others by mines or boarding teams. 7 merchant mariners were dead. The threat was not theoretical. Mines, invisible and indiscriminate, now defined the boundaries of movement for the entire world's oil and gas trade. The International Maritime Organization's statement left no room for ambiguity. Clearing the corridor was not just a matter of restoring commercial traffic, it was a humanitarian imperative. Insurance underwriters began to suspend coverage. Cargoes worth billions sat idle, crews stranded aboard tankers and container ships, waiting for relief that would not come from diplomacy alone. Each day, the corridor stayed closed. The risk of further casualties and economic shock grew. The world's most vital maritime artery had become a hostage to mines, simple, cheap, but devastating in their effect. The pressure fell squarely on naval forces, especially those with the tools and doctrine to hunt and neutralize mines. The International Maritime Organization called for coordinated naval escorts and continuous monitoring of the corridor, warning that without a credible mine countermeasure presence, no ship could be guaranteed safe passage. The United States, with its legacy of forward-deployed minesweepers now retired, was left to answer with a new and unproven solution: the Independence-class Littoral Combat Ship, carrying unmanned mine hunting systems and a promise of standoff clearance. For the crews stranded in the Gulf, the distinction between technical debate and operational reality vanished overnight. The question was no longer whether the LCS was the right platform in theory, but whether it could deliver in the face of a live mine threat. The urgency was not lost on allied governments or shipping executives. Bahrain, acting for the Gulf Cooperation Council, pushed for a United Nations Security Council resolution to authorize force, explicitly tying political action to the Safe Corridor appeal. The crisis had moved beyond military procurement and into the realm of global trade, seafarer safety, and international law. Against this backdrop, the need for dedicated mine countermeasure assets was not abstract. The entire world was watching to see if the Navy's most controversial ship could answer a call that would have once gone to a fleet of specialized minesweepers. The stakes were measured not just in military terms, but in barrels of oil, lives at risk, and the credibility of the international system to keep commerce moving in the face of asymmetric threats. The U.S. Navy's transition from the Avenger-class minesweepers to the Independence-class Littoral Combat Ship in Bahrain unfolded with little fanfare, but its consequences are now being tested in public view. In 2025, the Navy decommissioned its last 4 Avenger-class mine countermeasure ships from Bahrain, closing a chapter that had defined the Fifth Fleet's approach to mine warfare for more than 30 years. That decision left a conspicuous gap in the region's defenses, one that would soon be filled by a platform with a controversial reputation. On May 27, 2025, the Navy announced the arrival of USS Canberra LCS 30 in Bahrain. Canberra was the first LCS to deploy to the Gulf with a full mine countermeasures mission package, an array of unmanned surface and underwater vehicles, advanced sonar, and remote mine neutralization systems. The Navy described Canberra as the new principal mine countermeasures platform for U.S. Central Command, highlighting its ability to operate at standoff distances and to deploy unmanned systems into minefields where older ships would have been forced to risk their hulls and crews. By early 2026, official fleet trackers listed 3 Independence-class LCS hulls, Canberra, Tulsa, and Santa Barbara, as home-ported in Bahrain. The Navy's public posture was clear. The Avenger class had been replaced, and the LCS was now the backbone of mine clearance in one of the world's most dangerous waterways. The tracker update on March 9, 2026, reinforced this claim, naming all 3 ships as the forward-deployed mine warfare force in the Gulf. This official narrative projected confidence and readiness. The LCS, for all its engineering baggage, had become indispensable by default. Its modular mission bay, large flight deck, and integration with unmanned vehicles allowed it to field a mine countermeasures capability that the older Avengers could no longer provide. In theory, the new posture promised faster response times, lower risk to sailors, and a technological edge in the face of asymmetric threats. The Navy's message was that the transition was not only complete, but necessary for the realities of modern mine warfare. Yet the shift was not just about platforms or procurement cycles. With the Avenger class gone, there was no fallback. The LCS was now the only American answer to the mine threat in the Gulf. The expectation was clear. These ships and their unmanned systems would deliver the safe corridor the world's shipping lines demanded. The stakes of this transition were no longer measured in test results or budget lines, but in the ability to keep the Strait of Hormuz open under fire. The operational posture declared by the Navy set the stage for scrutiny, whether these ships would meet the crisis or expose new gaps in the nation's maritime defenses. The Freedom-class Littoral Combat Ship was supposed to be a leap forward in naval design, but by late 2020, a hidden flaw brought the entire program to a halt. Metallurgists at Naval Sea Systems Command uncovered premature cracking in the high-strength steel teeth of the ship's combining gear, the critical mechanism linking gas turbines and diesel engines for high-speed maneuvers and economical cruising. The problem was not isolated. On December 15, 2020, a Navy memo classified the defect as a class-wide risk, affecting every Freedom variant hull in the fleet. The same gear, installed across all ships of the type, had been manufactured with insufficient heat treatment and built to a tolerance that could not withstand the repeated torque spikes of rapid speed changes. The technical risk was immediate and severe. A single fractured gear tooth could trigger total loss of propulsion, leaving a ship adrift and unable to fulfill its mission. On January 19, 2021, the Navy issued a formal halt order to Lockheed Martin, freezing all Freedom-class deliveries. The Office of the Secretary of the Navy and NAVSEA jointly declared the vessels not mission-capable, refusing to accept any new ships until the defect was fixed. This decision stopped the final 2 ships of the class, LCS-31 and LCS-32, just before delivery, effectively capping production at 27 hulls. The cost of recovery was steep. Each retrofit required a redesigned gear tooth profile, a new heat treatment cycle, and non-destructive inspection of every in-service unit. By May 2023, the first repaired ship, USS Freedom, returned to the fleet, but progress was slow. 2 years later, the Navy reported that only about half of the Freedom-class hulls had received the fix. Each repair came with a price tag of $8 to $10 million per ship, a figure that did not include the operational downtime or the impact on deployment schedules. With the halt in place, the Navy faced a credibility problem that went beyond engineering. The combining gear defect was not a minor setback. It was a foundational failure that called into question the reliability of the entire class. Operational commanders could not count on the Freedom variant to respond in a crisis, and planners began to look elsewhere for hulls that could carry essential mission packages, including the Unmanned countermeasures gear now deployed in the Gulf. The technical breakdown of the Freedom-class propulsion system did more than delay ships. It forced a reckoning with the promises of modularity and flexibility that had defined the LCS program from its inception. The defect, the halt, and the costly retrofits became a warning to the rest of the fleet. Even the most advanced warship is only as reliable as its weakest mechanical link. In the shadow of the Hormuz crisis, the Navy's decision to rely on the Independence class for mine warfare was shaped as much by the failures of the Freedom class as by the needs of the moment. In 2021, inspectors found fatigue cracks spreading through the aluminum hulls of the Independence-class ships. Welds at the junctions between the central hull and side modules revealed hairline fractures, especially where the deckhouse met the side shell. These cracks, first seen on USS Independence, USS Chickasaw, and USS St. Louis, were aggravated by the Gulf's relentless heat and the stresses of high-speed maneuvers. Navy engineers warned that the pattern threatened the long-term survivability of the class, and by mid-2022, the issue was no longer isolated. The unique trimaran design, once a selling point, now posed a structural challenge under repeated operational cycles. Naval Sea Systems Command launched a reinforcement campaign, welding new plates over high-stress areas and ordering crews to inspect for fresh cracks after every high-speed transit. But the solution came with a trade-off. To protect the hulls, commanders imposed a speed restriction. No Independence-class ship could exceed 25 knots without special clearance. This cap sidelined the ships from their original high-speed, multi-mission promise. The vision of a fast, flexible warship faded, replaced by a vessel bound by strict engineering limits. The restriction put speed at the center of operational planning. The Navy faced a hard choice. The original plan for the Littoral Combat Ship, a modular platform ready for any mission, no longer fit reality. Critics pointed to the LCS as a warning about technical overreach. Yet, the Independence class still offered a broad flight deck, a large mission bay, and the capacity to host unmanned systems. While it could no longer chase fast attack boats or hunt submarines at speed, it could serve as a mothership for mine countermeasures, deploying drones and remote vehicles into minefields while remaining at a safe distance. On July 14, 2022, the Chief of Naval Operations issued a directive. All Independence-class hulls assigned to the 5th Fleet would be equipped with the Mine Countermeasures mission package and serve as the region's primary mine hunting force. This was more than a stopgap. It marked a doctrinal shift. The Navy recognized that the class's remaining strengths matched the urgent need for standoff mine warfare in the Gulf. Acquisition funding was redirected, mission package integration accelerated, and the LCS future was now tied to its performance in mine warfare. The first operational test came in 2023 when USS Chickasaw completed a joint exercise with the 5th Fleet. The results were clear. The LCS-based mine package cut clearance times by nearly a third compared to the Avenger-class minesweepers. Unmanned vehicles swept broad areas of seabed, while the ship stayed outside the threat envelope, and sonar data was processed in real time. The Independence class, limited in speed and structure, had found a role that fit its design, serving as the centerpiece of U.S. mine countermeasure strategy in the world's most critical shipping lane. Task Force 59's mine countermeasures rely on unmanned systems working in layers, each designed to keep crews and ships at a safe distance. The Littoral Combat Ship's mine package brings together unmanned surface vehicles, underwater drones, towed synthetic aperture sonar, and remote-controlled neutralization subs. All are coordinated from a ship stationed miles outside the minefield, shifting risk from sailors to machines. The operation starts with a diesel-powered USV launched from the LCS. Towing advanced sonar, it scans the seabed for anything suspicious. When sonar detects a possible mine, an autonomous underwater vehicle moves in for a closer look. If confirmed, a mine neutralization vehicle, a small remote sub, delivers a shaped charge to destroy the threat. In a 2025 Gulf of Oman exercise, this system neutralized 95% of buried mines, far surpassing the old Avenger-class ships. Navy doctrine is clear. The host ship must stay at least 2 nautical miles from known mine threats, ideally 4 to 6 nautical miles, while the unmanned suite can work up to 12 miles ahead. Real-time sonar data streams back to the LCS, letting operators control every move from a safe distance. Task Force 59's planners see this as the only way to keep the shipping corridor open without risking a billion-dollar hull to a cheap mine. Yet, the system has limits. Shallow water, silty bottoms, and strong currents cut sonar performance and slow drones. Detection drops by 15% in water under 15 meters, and tidal flows can halve sweep speed. Even so, unmanned standoff remains the Navy's best hope for clearing mines quickly in a contested strait. Official statements insisted that the United States Mine Countermeasures Force was ready in Bahrain, but the digital record told a different story. On March 15th, just 4 days before the IMO Safe Corridor Appeal, open-source ship trackers and port photographs placed USS Tulsa and USS Santa Barbara at the North Butterworth Container Terminal in Penang, Malaysia. The timestamp, 6:30 UTC, left no doubt. Local spotters uploaded images of both ships alongside, their hull numbers clearly visible, far from any Gulf minefield. 2 days later, at noon on March 17th, Tulsa's automatic identification system pinged from Singapore port waters. AIS logs showed no return signal in Bahrain or the Gulf during this window. Meanwhile, satellite imagery captured at 3:45 UTC on March 18th placed USS Canberra in the Indian Ocean, east of the Maldives, hundreds of miles from the Strait of Hormuz. Canberra's course suggested a long-range transit, not a rapid redeployment to the Gulf choke point. While United States naval trackers and public statements continued to list all 3 LCS hulls as Bahrain-based and mission-ready, the hard evidence pointed elsewhere. The supposed mine countermeasure backbone of the Fifth Fleet was split between Southeast Asia and the Indian Ocean at the peak of the crisis. For the merchant crews stranded west of Hormuz, the reality was stark. The ships meant to guarantee their safety were not on station. The contradiction between official posture and open-source proof was impossible to ignore. In a moment when every hour counted, the absence of USS Tulsa and USS Santa Barbara from the Gulf raised a question that cut through technical debate. What happens when the only available mine hunters are not where they are needed most? Today, the Navy's most criticized hull now sits at a global choke point, not by design, but by necessity. The flaws of the LCS are not erased. They are simply repurposed by crisis. In mine warfare, standoff distance and unmanned systems can mean the difference between disruption and deterrence. The uncomfortable truth, sometimes the ship you have is the only one that can hold the line. What do you think? Does necessity redefine utility?